Hi everyone, we are Team 19. I'm Ronan. Today our team is going to present our pitch for the project, Modeling Immune Responses in Python. We are fortunate to be advised by Dr. Andre Ken on this project. Now let's focus on the current problems of the medical experts. They perform various experiments and collect different kinds of data on a daily basis. The majority questions they always face are the following. What this data is all about? Is there any way to visualize this on computer so that they can plug and play with the data? What information can be inferred from this data? How to predict the future immune responses of the cell from the captured data? So these are the most common problems that they face on a daily basis. Thus, a solution to this problem is very essential to understand the basic data analytics. In the industry, there are many different solutions to overcome this problem. Nowadays, medical researchers use visualization toolkits to get a better insight into the data. To perform the mathematical modeling and predict the future responses, there are different models available in different languages. In this way, the medical experts can understand the data they capture and perform further analysis using visualization toolkits. However, a wise person has said every problem has a solution. There is a way to do it better than find it. I would like to call my teammate Tian to showcase the issues in the current solution and introduce our framework rules.
Thank you, Ronan. Hi, everyone. It is Tian. As Ronan said earlier, the current situation has some issues. I'm here with my team introducing to you RUSE, which is a generalized visualization framework for modeling immune responses. The major advantage in the current situation is that one needs to use different modules and framework to get the statistics. Compared to the current toolkit, RUSE has these following advantages. It has a seamless user interface. It also has a very simple, easy to follow execution pipeline. To overcome the problem of using different mathematical modules, it has the integration of mathematical components inbuilt. The commonly used data formats are supported in the rules for generalization and access in different operation systems. The major advantage is that RUSE supports multiple plotting libraries, such as thus a user can plot various graphs in a single time frame. In the next slide, we can see it has a very simple user interface where there are only a couple of buttons present and all have a very simple operation to perform. As we talk about the early, it is easy to follow execution pipeline. We will quickly get an overview of it. The pipeline have 4 stages where a user will collect the data. It will get loaded into the RUSE. You select in the inbuilt mathematical module and choose the parameters, and all the visualization will be displayed on the screen. Pretty simple, right? Thus, a single sentence can make the lives of research easy to gain insight into the data. Get the data, load into the RUSE, set up the parameters, and let the RUSE do the work for you. RUSE has some inbuilt mathematical modes integrated into the system so that the user don't have to worry about using other third-party modules to perform mathematical operations. To make it access and more generalized to use in other systems, it supports that the most commonly used data formats such as CSV, XLS, images film, and JSON formats. Now, to give better insight into the most advanced feature, I will call my colleague Randy to present the multiple planting feature. Thank you.
Thank you, Tian and Runan, for giving a brief introduction to the current problem, the solution, and why we need the rules in whole this visualization framework. Now, talking about the most, as Tian said, the most advantageous feature of the whole rules is the multiple plots. So a user or a medical expert can have a flexibility to use different plots to showcase in the whole one screen. So consider a user has a flexibility to see bar chart or a line chart or a scatter plot or even a distribution chart of the whole data. So it can have a more insight like to pre-process the data in order to get the model prediction. If a user has to do that, he can have the flexibility to do in the multiple plotting feature as well. So covering all most basic part of a ruse has a seamless user interface. It supports most commonly used data formats. It has inbuilt mathematical modeling components in it. It also has a multiple plotting feature, which is the most advantageous feature of all other frameworks. And finally, it has a simple execution pipeline. Now, talking about the whole project development pipeline, we are following the agile project development in which we have set two different releases. So one release is, which is of the milestone, and the other release is which is of a final product or full presentation demo. So in both the milestone, we are following two different sprints, and each sprint has a different task to finish. So first of all, we are aiming to get the data formats sorted out. So we will implement the data for we will implement the data formats so that the user can upload any of the data in the system, which are CSV, XLS, or any JSON or image file. The next part of the milestone of the sprint we are looking is of the user interface design. So with meeting with the client every week and communicating with him and getting a feedback, we will finish the milestone in a two different sprints. And finally, we are also looking to after finishing the first milestone, we are looking forward to implement the backend as well as the final product rules at the end of the final presentation or full demo. So this is the whole release pipeline we are working with, and by distributing equal tasks among our team members, we are cardinally coordinating with each other in a nicely manner. Now, considering the feature scope, our team is also looking to enhance some more advanced feature in the extended version of the project if it's feasible. So considering the data formats, we are also looking to improve the support to have more data formats supported in the rules. With the with getting the feedback from the client, uh, we are also looking to have a more advanced mathematical model inbuilt in our rules, which is use of a deep neural networks or deep learning models in the system to get access to different devices such as mobile and iPads. We are also looking to support the rules framework to different platforms so that a user can have more flexibility to use the whole framework in different devices. And finally, we are also looking to give user a more flexibility in the user interface. So like a user can design a user can design the whole user interface based on his need. So so in the API version, we are also looking to support the advanced user interface for the user's flexibility and feasibility. So in the whole pitch presentation, we have covered most of the important parts, which is the major problem or current problem of a user or a medical experts. In our case, we have provided a current solution, which is the use of different visualization framework and different models to incorporate mathematical operations to get the insight of the or prediction of the data. And we have also gave a brief insight into the rules framework, which has many features to showcase. And our whole complete project development pipeline has also been showcased in the full presentation. So we are looking to develop the rules in a nicely fashion. So thank you for listening to our presentation, and we are really looking forward to showcase our rules at the end of semester. Thank you.